All right.
Hello?
Hello, can you hear me?
Oh, yep.
Sorry, keep you waiting.
Oh, it's all good.
Let's go
Yeah.
to now. Shall we share the screen or do I go?
Yeah.
I got your textbook now. What shall we do with?
Yeah. Today we did a practice test
Aha, go on.
for calculator free.
Okay, kind
So
of free. Yeah, you got analytical formula, right?
yeah, like some of the questions are pretty simple, like uh draw the resultant vector. So I just have to connect some vectors up and draw something.
Oh, graphic. This
Uh,
graphic, right? It's just
yeah,
graphic.
and then other questions are like it was mostly vectors,
Uh-huh.
like if these two are parallel,
Yeah.
find the unknown or something, or make this polar form. There
Yeah.
was proof as
Mhm.
well. Pretty
Straightforward.
simple proof.
Oh,
Yeah,
good.
some one of them was hard, but it took time. But
Uh-huh.
eventually, in the end, you get it. It's a bit difficult, but eventually you get it.
Oh,
But
that's good.
there was one for forces, which
Uh-huh.
was very similar to what we did last night.
Oh,
But
good. Good. Good.
yeah,
Mm.
the only one that I couldn't really do
Yeah.
so was prove the diagonals of a parallelogram
Yeah.
intersect at the midpoints.
Okay, we can use vector formula to do that. Vector,
Yeah,
yeah,
it's a vector proof.
yeah, vector
It's a
proof.
bit
Yeah,
yeah.
I think we have done something similar to that. Do you want to go
Yeah.
to whiteboard? Just
Yep. I'll just
recall. Yeah, I just share my screen first.
yep.
I prefer you have to probably use a dark background. It's better. Otherwise, I getting tired. So I wanted to
Yeah.
put the
So
dark. Yeah, is a
it's
parallel. Yeah.
12 questions, 45 minutes was what we had, and it's going to be
Okay.
similar.
Did you say it's a parallelogram?
Yeah, that's right. It's
Okay.
prove that the
Okay.
parallelogram
Yeah.
intersects midpoints at the
Yeah.
midpoints.
Good. That's good. That's interesting question.
Oh yeah,
So
black background's pretty good.
yeah,
Yeah.
that's right. I use this diagram. So basically, I'm looking for the two diagonals. These two diagonal.
Yep. It
Two
intersects at the midpoints.
at
Yeah,
the
that's right.
midpoint. Okay. Well, I think we have done that before. Did I? Did we?
I'm pretty sure. It's just that when it said intersect at the midpoints, did that mean the midpoints of the lines, the
Of the
orange lines?
of this parallelogram. Yeah. Of course, it's
Yeah.
half. It's half. Yes, it's certainly a graph. Yeah, it's half. So. Do you remember how did we do that? Did we just let me see how did we do that? I just trying to recall. Can we call this A B C D?
Oh
Can
yeah.
we call this A B C D? Or can we call it E here? Can we E here? A B C D E?
Yep.
A B C D E at the center. So if you use vectors, we have two strategies. One is use the half. Do we use half? We just recall. Do we call this one vectors, or we call which is easier to prove? Can we use half?
Oh, like you split each side into
Yeah,
half. Oh,
yes. Can we do the half?
yep.
So this would be our T1. That would be the half. And there's another one. I will just go to half. Okay. Probably
Yeah.
this advantage to this one will be it will be easier. We just introduce this half. Can we call them the proper name? So this
Yep.
is I think they are probably don't. I don't want to use too many variable here, but can we just can we call this A?
A.
This is B. This
Yep.
is C, and this is D. Okay.
Yeah.
There's vectors. So what I'm trying to do is that we just introduce the vectors. So the A, B. So A, B vector will equal to 2A. Well, for some reason, I think it will be we can simplify this easily, all right?
Yeah. Yeah.
And how about BC?
BC is equal to 2B.
2B, yes, good. Similarly, CD.
2C.
2C, yep. Oh, you can write from your side. How about DA?
Oh, yeah.
dA 2D, right?
equals 2D, yeah.
Okay, now what we're trying to do is that we want to know if this is, can we put this, so probably simply, can we work out this this side as the sum of these two?
Yeah. As in
yeah.
AE? We want to figure out AE?
I can't remember clearly if we use this strategy or not. Did we use this strategy?
Yeah, we did. And then I think we had to solve for like
several equations, right? We have to solve several equations.
I think it was like A is equal to negative C. Like because they're like parallelograms have.
Basically, I just use different kind of. We're trying to we just draw the attention of this. We just want to see if these two are the half. If this is just half, okay.
Yeah.
To do that, we got.
I think I'm.
Do you remember?
So
that would be, how about, this will be D. Can you see this also will be the D. So that's why.
Yeah.
I forgot the actual. This is also D. Can you see? So from this one, we can argue that all these can be written as the combination, linear combination of. We just can write it down one of them. Linear combination of these four basic vectors. I think that's the strategy we used. So basically, can we start first?
Sure.
Yeah. So AE. So this AE were equal to what's the relation between them? AE would be
A is equal to. I thought we just
AE plus. This AE plus will equal to A. I will just can we just first read from graph? So AE were equal to
AB plus BE.
A plus minus let's just rewrite this equation. Because sometimes you will just go to the beginning. So A will be the sum of the AE plus D. Do you agree? That's our first equation. Okay. Right. Yeah. So similarly, how about the EC? How about in this triangle? How about the EC?
EC will equal.
Can we just draw this one? Can we EC? Can we just we want to show this identical, right? So basically, this is our. I just use a red color.
Yeah.
Different. So many different colors. So this is this EC. Can we just shift the B here? B were
up to there.
Yeah, up there. Yeah, we do the. I think that's how we did that. So that's
yeah.
That would be our B. Okay. Sorry. Right.
So cool.
This will B. Can you see? There will be the B. Okay. Yep. Now, what equation can we write? Or you have wrote something. I noticed.
Oh no, I'm just checking, like just checking something.
Yeah. So basically, I will see here that the AE. Can we say AE will be the sum? Okay. EC. Can we say EC? EC plus C. Right. EC plus
C.
Plus C. Yeah. We're equal to this angle. This is equal to B.
That's B. B. Yeah.
I think that's how we built this equation. Now, similarly, we can build these two. How about these two? How about these two numbers? How about these two vectors, rather? How about this one? How about this one? There's another vector here.
BE. BE is equal to. So there's you can use D.
Two vectors. Yeah, we're just trying to build these vectors.
Yeah.
Another formula is that the sum equal to, yes, that's how we do it. The sum will be equal to 0 of this. Yes. Can we just write down one by one? We're getting there. So basically, Now, can we just write one more? Can we look at this triangle? So this triangle, that will be the BE. BE, can we just look at BE, Victor?
Yeah.
BE will be the sum of the B plus C, plus C, right? Now, finally, how about the ED? ED.
ED is equal to
B plus C.
B plus C.
Plus B plus C. Is that right?
Yeah.
Oh, they already proved, you see. Therefore, from this one, we have proved that BE, can you see first result come out equal to ED?
Yeah.
So that is half. Okay. Now can we prove AE equal to CE? Can we prove AE equal to EC?
So we've got AD and we've got CB. Oh, we've got the two opposite ones, AD and CB.
Yeah, can we prove that?
Well, you know that
A equals... we know that D. Another thing is that, finally we know this. So they got 2A plus B plus C. I think that's how did I do that? And D equal to what? The sum of all these vector equal to what?
0.
Yes, that's right.
Yeah, so I was, that's right. So
is that enough to solve? We have proved one of them. We have proved this one of them. Can we just pick up these three together with this additional constraint? Can we prove the second?
Yeah.
Do you want to try?
Yeah, I'll just quickly write this down.
Yeah.
CD plus DA equals 0.
Yeah.
I think last time we wrote something like A B plus CD was equal to minus BC minus...
Oh, we don't have to go that far. Can we just start from here? We don't have from scratch. We can we just pay attention to these three questions here? Now I just trying to finish this very quickly. From this one we got AE. So from equation 1 and 2, we got AE. Can we find AE? AE will equal to A minus D. Do you agree?
Yeah.
And the CEC, we just want to know if these two vectors are identical. AC equals to what?
EC equals B minus C.
That's right, B minus C. Now we just want to prove if these two constraints can be proved by the third equation. I'll
just try A equals negative C, B negative D. If you substitute...
Oh, no, we don't know. How do we know A equal to negative C? We don't know.
Oh, yes, because...
You're from this diagram here.
Yeah, from the diagram. Does that work?
Can we just work on this question? I just want to, now I'm just looking for algebraical or analytical formula. Okay.
You can, now, if you know this.
No. Can we just rearrange this formula, okay? Okay, can we just rearrange this formula? So what we need is A minus D. A minus D? No, how can we get that one?
Oh.
Can we minus? Can we minus them?
Well, you know A plus B equals
if we assume A plus D. If we just minus them to see if they get 0, they get cancelled, okay? We put the question mark here. Then that will be A minus B and minus D
plus C.
Plus C. We're not sure. Are these equal to 0? We're not sure. We have trouble.
I'm pretty sure it should be because
just double check.
Well, from this formula you can write. Oh, I was just thinking, why can't you, from the diagram,
Yes.
what I wrote here, isn't this correct though? Like from the diagram?
A equal to negative C and B equal to negative D. Oh, yes, I think
Because it's a
so. Yeah, that's right. I agree. Yeah, I agree.
parallelogram.
Yeah.
Yeah, parallelogram has opposite sides, so half should be equal
Yeah,
to half,
because
but
it
it's
must
opposite.
yeah, because the corresponding opposite side are equal. Yes,
Yeah.
yes, that's right.
So if you use this, you can prove the A
This one
minus
correct.
D.
Aha.
Yeah, you can prove it. You just have to substitute to show that they are equal.
Yeah. So A equal to minus C.
Yep.
And oh yes, yes, they're identical. Okay, you are right.
Yeah.
We solve it. We solve it. We don't
Yeah.
have we don't use this formula. We don't use this formula. We use this one.
Yeah.
Oh, good. Okay. Oh, thank you. You helped me to record this.
Oh, thanks.
But that's what I suggest because I just think I will. We did use the summation, right? But today we didn't use
Yeah.
that condition. I hope
Yeah.
that will be the method to go, or perhaps
Yeah.
you can looking for something even simpler.
Yep. Just one question.
Yep.
So you wrote like here you wrote D, and then you move it along BD, and you can write it here.
Mm-hmm.
Is that like that's not an assumption sort of right? That's perfectly valid, right? You can
Well,
just rearrange.
you see ABCD are, well, we treat ABCD as a nature, as a property of the parallelogram. If
Oh
you,
yeah, okay.
yes, we didn't, no assumption is made. And just for
Oh,
convenience, we just half them, you see, we just use the
oh,
half.
you're right.
Yeah, yeah,
Because if you half it like
yeah.
across here, that makes
That's,
sense. Oh,
okay.
now I get it. That makes a lot more. Yeah, that's very clear. Oh yeah,
Yeah.
I see that. I see that. Oh yeah.
Okay.
Now it's yeah. So that's the thing. Yeah, that's the only question I couldn't get. It's just
Okay.
it's just I spent a long time on one of the other proofs, but then
Yes,
eventually I understood in the end.
that's good. That's good.
Yeah.
So,
And yeah, but I think tomorrow we might get the other test for the calculator with the calculator.
it's
But
calculate,
yeah,
yeah.
yeah,
I just trying to find out where is the textbook you sent to me? Oh, specialist. Okay, this is specialist. Yeah,
yeah.
specialist. Do you want to pick up some problem from your textbook?
Oh yeah, sure. I'm I'm most likely sure that all the all the permutation combination
Yeah.
questions, they're probably all gonna be calculator because there was none in this exam.
Oh,
There was none in the calculator free.
yeah. Otherwise, the factorial is the number is huge, right? Could
Yeah,
be.
yeah.
Yeah.
So that's what I'm thinking. But yeah. Is there anything else? I just double check if there's any other questions. I just didn't know how to
You can
do.
just pick up any question we can discuss. Focus on the topics to be examined.
Yeah.
Just build another page. I build another white dark page here. You go on. You
all
just
good.
you just.
Yeah, it's a short exam, 12 minutes, so it's 45 minutes. So yeah, it's all good.
Okay, it's good. Can you recall any other strange equations? Questions.
Strange questions. Let me look at this. No, I think that's all good. Yeah, it's all fine.
Okay. Well,
yeah.
we do have some time. Can we just use your textbook now? I just prepared a few. Can we
Yep.
choose a? You can choose some problem relative. You see, after the test you had today is that will give you some guideline direction to go, right? Otherwise, you don't know what they are going to ask. Now, based on this information or knowledge, can you just pick up any question we can solve together?
Yeah, I'll look at my textbook. I think I have a couple that are a bit more difficult.
Yeah. Says
so
you get me a page number. I can go there. I can jump there.
Yeah. Let's look at this one. Exercise
Page number, please.
Oh, sorry. Page number. Oh damn. Okay, I need to open the. I was looking at my OneNote. I just got to check the online copy real quick.
Oh, you got 2 books, right?
Yeah, Cambridge. It's just vectors, I think, is the.
Oh, we can focus on vectors if you want to.
Yeah.
You see, when you're doing a vector, you have to just record the graphical difference.
Yeah.
Okay, we often use the sum and difference. If you know that one, that will help you to solve other problems like relative velocity yesterday. You agree? So
Oh yeah, relative velocity.
Yeah,
Yeah.
you have to use that diagram, a graphic method all the time. That is like the go on.
Yeah, actually, I think because I haven't done permutations in a while, probably
Permutation.
Chapter, so page number 100 and
100 something.
200 and like 26, 226.
26. Okay, 226. Okay, 30. Okay, yeah.
Oh, this is just the extra. It's just counting.
Yeah,
After,
counting. Yeah.
Yeah.
It's just the restriction or not? Counting.
I don't think there's it's just counting in general, I think.
Which exercise? 7F or?
Oh, I'm sorry, I'm looking at the wrong. Oh no, I'm looking at the right chapter. Yeah. 7. It's in 7J.
7J. A B C D E F G H I and more. J. 7G is G or J?
J.
J H I J K or more.
Page 226.
No,
225.
More than that. 2H is different numbers. Why? Hang on. Yeah, this number is different from the PDF. Okay. Is it still? Oh, I see. That's quite amazing. It's different. 15 numbers. There are 15 pages difference between the two.
Oh.
I have to go further.
7J. Did you find?
Yes, that one. Yes. Oh, more than that. It's not easy where to jump to the particular page. 8A now. It's 7J, right? It's 7J.
Yeah. Probably a bit too far then. Yeah.
Yeah, too far. I will go back. Extended response question. 209. Yeah, 229. 226 something?
Yeah, 226.
226. Yep, I got it. Number 9. Number 10.
Yeah. 226. Oh, does it say a bag contains 5?
Yes, that's right. I saw that page. Yeah, that's the page.
Yeah, just from here, I think probability is my weakest section overall.
Is it probability? Oh.
It's like application. Yeah.
Okay. Number 9. Let's try if you can encounter any new ideas. Number 9. You see? So what is condition given? Bag contains 5 white. Oh, 5 white. And 6, right? 6 red.
Yeah.
Oh, you have picked them up one by one?
Yeah, and 7 blue balls.
Yeah, blue. Yeah, that's different color. Can we just call it B? WRB? Yeah.
Yeah.
So what is required? If 3 balls are selected at random without a replacement, find the probability they are all red. So the only thing you need to take into account, if you just return, then the total number will be reduced.
Yeah.
Right? So the probability, what's the probability? By definition, the probability will equal to the particular situation, the xi, will equal to this total number, right?
And over the favorable.
Over the favorable, that's ni is ni. So ni correspond x equal to xi.
Yeah.
So when you play this game, that each time you pick up 1, they only have a find the without replacement. So that is the key. So every time the total number decrease, that's n. So next time will be n minus 1. Can you see? N minus 1. So I have to be careful. That's n minus. That's called the sample size, right?
Yeah. Oh yeah.
Then just go. How many times? How many times they do this again to put this in until what?
That's it. 3 selections. Yeah.
That's all.
Yeah.
The back contains possible. Find the probability or rate. How many times do? Oh, 3. Yep, that's enough. So 1. They pick up 1, 2, 3. Yep, 1, 2, 3. Now, do you want to calculate probability or rate? Oh, that's very restricted. So the number will decrease depending on whether rate was picked up. Okay.
Oh, okay.
Can we use a tree diagram will help you? Can we use a tree diagram? We got 3 directions to go. Can you see? That is pick up your red, and that's pick the white, and pick up the blue. Okay. So what is the chance to pick up red? What is the total in this case?
There's how many people? There's
how many balls?
18.
18 altogether. That is 18. That's probability pick up from the how many red one?
6. There's 6 red balls.
That's it. That's probability to pick up the first ball is red. Okay. Yeah. Now they ask for the second is red. Wow, that is something interesting. That's this is the second time. Okay. Can you finish this tree diagram? So this is still red. Okay, they're still looking for the red. So what is the not opportunity? What is a probability here? If you write it in fraction, you say probability can in general written as a fraction, right? It's always written as a fraction. The ratio.
Oh, whoops, mistake at the top.
17. That's right. 17. That's correct. How many balls left? Good. Yes, you're all right. Why did you say you are not confident? You're all right.
How would you use, I'm just not sure how do you use combinatorics here?
Oh, you don't have to use the formula. We must find the probability, okay? That's a solution we need to find the, well, we do see another because this is not necessary for the counting. They are trying to find in particular for the probability. Okay.
Yeah.
Probability is different from the to count the way you actually arrange the object. That is the permutation and the combination. It's different, right?
Yeah.
Now this time they just looking for probability. Now let's finish that first. And they ask for the third time is red. So what is the probability? So you got P1, can you call it step 1?
Yeah.
Step 2. Now they're still looking for the third one. That's right. Probability 2. Now to make this happen, which rule should we apply? Multiplication rule.
Multiplication rule?
Yes. So the totability, that is A, okay? The totability will be the product. Okay, can we use a product?
Yeah.
I from 1 to 3. Or just equal to 1, okay? 1, 1, 2, 3. Can we just put a number here now? What's P1?
Yeah.
6 of 18. You can check from your result to see if that is correct. Okay.
Oh yeah.
Okay. You can write that from your side as well.
Yeah. So
you want to check? You are not use calculator, right? During the exam.
Yeah.
Okay.
I think so. So that would equal if you this is 1/3.
You have this or you can simplify.
Yeah. Oh, I've got a calculator here.
Yeah, calculate. Yeah, you just compare with your result to see if this is correct. I think it's correct because method is right. You see.
Yeah. So but just is there any way that you could show combinations though? Just
no.
way?
I have answered the question because we have got to answer first. Okay. They didn't ask you. They didn't say, hey, we must use the knowledge of the permutation. Combination.
Yeah, that's true. They didn't ask. Yeah.
I will say the context because we jump to this question. What is the context in this section? Okay, I will say why they have asked the question in probability. Because
Yeah, I'm not
you just use calculator. I've been searching for that for a while. Okay, you just use your calculation.
Yeah. So since it's total.
Acquired probability. Yeah, that's actually the introduction to probability. Okay.
Oh, okay.
Introduction
Yeah.
to probability. 42.
Yeah.
When you're trying to work out probability, there are always you always have involved the way how to count. Okay.
Yeah.
Number of outcome. You see, that's introduction of the probability. You see, total number of outcomes. So the outcome.
Yeah.
Okay. Application to probability. In this section, we apply our knowledge of permutation combination to solve probability where there are equally likely outcome. Probability is studied by mathematical methods too. For the section.
Oh yeah. Oh yeah. I figured out. Yeah. Oh yeah. This is probably yeah. This is a good way of doing it without. Yeah. I got it. I understand now. Yeah. You don't need to use combinations. You could just use this like just probability like this.
Yeah, you just work out the ratio. You see, you are more interested in the ratios. Of course, you have to. Yeah, I think it's different. This is a different subject. Although they just put, you see, some editors just put the irrelevant subject together sometime.
Yeah.
Okay? Now, but I must agree that the counting method is relevant to calculation of probabilities, right?
Yeah.
So sometimes you have to work out, how many outcome. For example, give a die. The outcome is 6. Okay, there are 6. However,
6 outcomes.
Yeah, if you say they can ask question alternatively. You say if you have 3, you have 5 ball in the basket, right? Different ball in the basket. They were how many outcome? They just change the words. Just manipulate is how many outcome would be if we just every time we have put into a proper order. So that became permutation. Do you agree?
Yeah, 5 balls in a basket, 5 factorial, right?
That's right. But this is, I think, counting is part of the study of probability. Do you agree?
Yeah. And the whole chapter is counting. Yeah, you're right.
The more outcome you have, and the chance to find individual event is diminished or reduced, right?
Yeah.
Otherwise, if you study condition, do you have to study? Are you going to have a Math B as Ryan have Math B?
Study what?
Yeah, Ryan said he's also going to have exam test for Math B.
Yeah. Oh yeah. That's, you
see,
I think after this one.
If that's so, I remind you have to pay some attention to the conditional probability. Okay.
Oh yeah.
Because
that's tough.
when you come, no, it's not. I actually talked to Ryan for a few weeks. He seemed to understand everything. It seems that you see when you encounter the conditional probability, you have to recount the sample size. You see, when you have to recount the all outcomes. So counting is essential for study the probabilities. Although sometimes we don't have to use the. Do you remember sometimes when we solve the problem of the combination or permutation, we just follow that the multiplication or additional rule.
Yeah.
We didn't apart from this basic formula, arrangement formula. We still use other relevant knowledges. Do you agree?
Yeah, that's true.
So I think some textbook treat combination or combination as independent subject, but others, like this one, like the Math C here, they treat it as just relevant to the study of probability. I think it's logical. Okay.
Yeah.
Now, if you study everything in isolations, you lost, the interest. Actually, you lost the color. You lost
apply
the color.
it to the.
You have to apply them, the knowledge, whenever is needed. Just because we have learned something doesn't mean we have to exclusively use that knowledge.
Yeah.
Anyway, can we go to another question?
Yep. What about the next
Number two, right? Number two, question number 2.
10? Oh yeah.
Same
This
question.
number.
Number 9. Number 9.
Oh yeah. Oh, find the probability that they're all different colors. I think I can probably do this.
You want to try? Yes, that would be interesting.
I could do it both ways. Either I could do a tree
Combination?
diagram,
Yeah.
or I could do combinations, I think.
Okay, fine. Up to you. It's 9. Yes, still 9. Number B, right?
Yeah. So it was, the formula was it equals, so the probability of was it n equals,
Well, you are looking for the probability. Can we just write the proper notation? You are looking for the total probability, okay? The probability will equal to summation of each color. So each color. So can we just get this color? So can we just put the formal notation here? So that's x equal to xi. I means the colors. So right.
yeah.
That is I from 1 to 3. Or you just say all colors. You just addition.
Yeah.
Do you agree? Do you agree? We use
Yeah.
additional total outcome. Oh, no. I say, in this case, we just find them together and then use the probability. Can we this call for the rate? Okay.
Red.
Yep. Yeah, that's how to write. Can we
Oh yeah, probability of red.
Yeah, red plus probability white or green or blue.
Yeah. It was red, white, and blue.
And blue. Okay. That is so that's how we denote the probability. We use capital X. So this capital X means a random variable. So it's a random variable. Okay.
Yep.
Discrete.
Over the
It's called a discrete random variable. Okay. Yes. So we have found this one. Can you see? We have found this. Which one? We have found this one already. Okay. So we need
the probability of Yep.
Then you need to find the all others.
Yep. So there's how many reds are there? There's, if using combinations, you could do.
Yeah, you can use combination.
Yep. So it's like, I think it's 6 for red, C 1.
You choose one from 6, yeah.
Yep, and then 7C1, and then 5C1 over the total outcomes is 18C3.
Altogether.
Yeah, is that right?
Double check if this is consistent with our C. Okay, how about the 18C3 will equal to 18 factorial, right?
Yeah.
Times 3 factorial, 18, that's 15 factorial. 15 factorial, okay? So we can cancel 15. So we got 18 times 17 times 16. Then we can cancel this by 6. Okay, that's all.
Yeah.
Right?
I got 816.
Yeah, can you double check with our, but it's different from our numbers. That's interesting.
Oh, wait.
Our number of total ball is just finite, 18 something, right?
Yeah, it's, oh no, this is the number of, this is different, right? It's like total outcomes is,
once, you do it, you play this game once, okay?
Yeah.
You play this game once. So I think this is irrelevant. This number is do you call this the sample size? I don't. What do you call this number?
Like, I think it's different if you use combinations, unless if you use probability, because in the last page we used
it's too big as a number.
Yeah, it's number of outcomes over total number of outcomes.
No, listen, let's just recall what is a combination. The combination is that there's a total number 18. You pick up 3, right?
Yeah.
How many ways to pick them up? However, this is that's irrelevant, right?
If you have
3, but how many times to do this experiment? It's different from the original design. You see, if you go back to the question itself, number 9, this says the bag contains a white 5 white, remember, are selected at random without replacement.
Yeah.
So I think this is you have I think you have to be careful. I think a combination doesn't count in this case.
Yeah. I mean, for this.
You are doing so. The test is different, you see, or the game is different rather, right? The original game is that the person each time pick up 1, okay?
Yeah.
And did that 3 times, and they ask the probability to see, you know, the outcome will be the same color, right?
Yeah.
But in your case, you say, well, we mix them up, okay? I randomly pick up 3 once, okay?
Yeah.
This is not the point. It's different. Can you see the difference between the 2 games?
Yeah, but in the end, they should give the same answer, right? Because for the last one,
I don't think so.
oh, because for the last one, I got the same answer doing
which one?
The red one. So if it was, I'll quickly just write it here.
Which
So
one?
6.
Yes. Which one?
Oh, yeah.
Page? Which page? This page? Yeah.
Yeah, this page. So if you so it was 6/18 times 5/17 times 4/16, which was 0.025, I think.
Okay, one moment.
And
I'll be back in a minute.
Oh yeah, all good.
Oh, sorry. I hear my kettle.
Oh no.
Kettle is I just talk water. Okay.
Oh, it's all good.
Okay.
Yeah. So this is the answer we got for the last question, and then you get the same answer if you do. So it's 6C3 over 18C3. I think this I calculated it equals the same thing. I think it's because.
Oh, you got the same answer. Yes.
Yeah, I think it's because in this you're using this, but in this you calculate the total every time, right? It's just like, yeah, it gives the same thing, but I can't really explain why. And I think it's probably because every time you get a fraction, right? But this is just one fraction, because this is just the possibilities of the top.
You are right. You see, because they are not pick up 3 at a time. They pick up 3 one by one, you see.
Yeah.
But doesn't it make any difference if they pick up 3 at a time or this?
Oh no.
Doesn't make a difference. Yeah, that's interesting. So if I play this game, I just simultaneously pick up 3 instead of putting it one by one. That would be the same. The probability would be the same.
If you pick up 3 at the same time instead of one by one.
Yes.
I think the fractions would stay the same, because the chance, because if you pick up 3, the chance your first ball, because you've picked up 3, so your first ball has this chance of being red. That means your second has this.
I mean simultaneously.
Yeah. I think it's the same, because even if you pick up 3, the chances of each ball being red is still the same as this. It's the exact same, I think.
No. That would be be careful. In my opinion, that would be how to say 6/18, right? Times 5/18. Can you see denominator? Because this is a simultaneously. The denominator is the same. Can you see? If you do it simultaneously, because when you pick up another one, the other 2 are still available. That's what simultaneous mean.
So if you pick up one red, I mean, you pick up one. You still have the other. Oh.
This is called simultaneous. You have
exactly at the same time. If you pick up the same.
Exactly the same time. Yeah, exactly the same time. You simultaneously.
Oh damn.
Have you think about this? I think this will be different. You see, you got 18, 12. That is,
Yeah.
this is 1 by 1. Yeah, I agree. I agree. This is 1 by 1. So 1 by 1. That's different.
Yeah. Well, at the so if you use it out simultaneously,
Yeah.
what does sorry, what is 6? I'll just because would you also say this is also the same as simultaneously? If you just pick up 3 of
Well,
this
in the
6?
first, I don't know. I'm surprised you got the same result. But my argument is that if you want to explain the difference, can you explain the difference between this result and this one? Because I think if you say, we have to return to the combination formula. So if you have the original definition, you have the you got the n ball here, okay.
Yeah.
And of course, in this case, we can assume the same arrangement, okay, different colors and different percentages, right? Now you
Yeah.
pick up the one, the orders. Obviously, you have to assume you to do it 1 by 1, right? Not
Yeah.
simultaneously.
Hmm.
You pick up
Well,
one.
yeah, if you pick up 1, then it's just the descending
Now,
fractions.
in
Like
term of probability, this number is called the sample size, right? It's called the sample size.
the bottom one?
Now, yes, right. No. Of course, if in your case, you say that you treat it as how to say. That's very interesting. You got identical numbers, right?
Yeah. But I don't think if you pick all 3 at the same time, I think it's still this. I think it's still this because even
No.
though you pick
Why this? Why this? Why is I
because
why you change this number? Why can we write it this way? Can we write 5, 16? Can we write it this way? So what is the way you write it this way instead of that way?
because even if I pick up 3 at the same time, so I reach into the bag, I pick up 3. So in my hand I have 3 balls, and if the chance that the first ball is this and the second ball is this, it's this top one. I don't think it's possible to do like have 18 for all of these. I don't think it's possible because even if I pick up 3 balls at the same time and I don't look at them, the probability that the first one is 6 out of 18, the second one is 5 out of 17, and the third one is 4 out of 16.
Oh,
Even though,
yes, this is just a statement. You just make a
yeah,
claim.
I think,
Well, that's right. This is your claim, okay? That's what you call at the core. This claim, someone claims something was right or something is wrong. But
yeah,
I just use my intuition, okay?
yeah,
Okay, that if you actually follow the simultaneous definition, if something happens
yeah.
simultaneously, then we have to say that the sample size remains the 18. Okay.
Oh, wait, what about 6? I think,
Now,
actually, if you pick up, sorry, if you pick up at,
go on.
if you pick up at the same time, isn't the chance for each one 6 over 18 either way? Because if you're picking up at the same time, then there's a even chance of getting each one, right?
No. Oh, that's assumption. Your idea is to treat these are the identical, no color. They are same colored. All the
Yeah,
balls are same colored. Then you can pick up this. Did you say it's 18 pick up 3?
yeah.
No, you
It's
didn't.
just,
You any color. So that means this is any colors. Any
yeah.
color. Okay.
That's the total number of ways you can pick up 3 balls of
Good.
any color. Just
Yeah.
pick up 3.
Yeah, that's equivalent to you do it not simultaneously. You do it 1 by 1. Okay.
Yeah, 1 by 1, right? Yeah, yeah. That's right.
Okay,
I'm not
that's
sure how
right.
you do it
Now,
simultaneously.
how can you rewrite your denominator?
Yeah,
What's your denominator? That would be interesting. So what's your
yeah.
denominator here?
Oh, it was for red.
Yeah.
You got 6. You got to pick up 3.
Ah, yes, that's right. Yeah.
Yeah, and then can you cancel these? Oh no, you can't cancel them out. There's no like. Okay, yeah.
Did you get your answer by using this cassette? 5 call for 8, or is there other? What are the other 3 terms?
Oh, for the second part of the
Yeah,
question, it would
yeah.
be so. For the second part, it's 6C11 and 7C1 because you have to pick one from each
Uh-huh.
for the. Yeah, I haven't calculated that, but I'll calculate it, and
Yeah,
then I could try we could try the other method
that's right.
really
Now,
quick.
now
Yeah.
can you work out this number first? So 6, that's easy.
Yep.
6 equal to 1. It's just 6 factorial, right?
Yeah.
This is 6 factorial. Right? This 6
Yep.
factorial. Yeah, you use calculator, probably we will see if
Yeah.
you can get any number closer to the previous result.
Yep. Divided by 18C3.
Did you see
So
you already got this number? Did you see you already got this number? How?
oh no, that's for the other question. Like in the other question, it was this,
That's
and it
number
was
9A, right?
yeah.
Question.
For 9B, it equals 0.022.
2. Okay, not 25.
Yep. No. And if we use this way,
Wait a
using the
minute.
trick.
Can you concentrate 2 minutes to finish this ratio to see if this number is identical to the answer?
Oh yeah, I have to calculate the other answer using it's the probability of getting one of each, which is it's so the probability of getting one blue, a blue is 6/18, and then
That's the first pickup. Yeah, first pickup.
yeah, and the probability of getting a red.
Mm-hmm.
Oh, this is red.
Mm-hmm.
This is blue. The probability of getting a red is 5/17. And then the probability of getting a white is 6, 5, and 7. Oops.
Oh, can you return to the question? They asked for probability. They are all different colors. So therefore, you don't pay attention to the color. That would be where you can introduce the combination formula to count the all outcomes, the number of the outcomes.
So
I'm still talking about question 9B. 9B.
9B.
So they ask for all different colors. So that's why
all different colors.
You can treat them as identical, you see.
I treat them as identical.
Yes. Oh, hang on, it's not simple. All different colors. Therefore, I still have to prefer to use the tree, you see.
Yeah.
Because the tree will give you the answer easily. So that's probably
I was trying to do the tree in my head, but I don't think I did it correctly.
So can we just work out this diagram? Can we repeat how to say finish this? So this RWB, right? So this is RWB. So this is RWB. That's right. So every time must be different. So if there's one way so that's one way. So one is red. Yeah. And next time must be different. Must be white. And then blue. Go to blue. Yes, that's blue. Yeah. This one way. It's just one of them. Another way is that.
There's more options, right?
Options, more than one. You have to.
Does order matter though? Does order necessarily matter?
I think we still have to. Well, this is just one of the numbers. A huge number. Okay, there's one way to go. Just ensure they are different. So in other words, you have two choices. They have two. So after that, they got the 2. After that, they got the 2, right?
Yeah.
And instead of the 3, because we must be forbidden, that must be different. So this 1, 2, 3. Okay, I think that can be solved easily by probability definition. So because we can work out each probability. each channel, the probability for or pathway for each pathway, okay? And we just have to sum at the last stage we have to count how many altogether.
Oh yeah.
Think about it. Think about if we can incorporate combination formula in this type of questions, problem solving.
Yeah.
But I think the tree diagram would be universal. I don't know if there's if it could be considered as a shortcut or. Okay.
Oh yeah. I think I got the same answer.
Same answer?
I think so. I probably 5, 5, 6, 7. No, I didn't get the same answer.
Different. Well, if the answer is different, we'd have to because the formula for combination is very.
Yeah.
The conditions are quite different from the game. That's my argument.
Oh, okay. 18C. The total number of outcomes is still 18C3 either way because it's just picking 3 balls from the basket. Oh, that's pretty strange.
Right? Ultimately, yeah.
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 I'll just double check with my teacher I'm not sure if we're even being assessed on this chapter. I'll have to double check because we haven't really gone. Yeah, but it's good because usually they put in like one question at the end. That's something a bit more abstract like this.
Yeah, challenge. Challenge.
So I'll double check if we're doing this with my teacher tomorrow. And
good. Okay, give some feedback. We can continue to discuss. But also you have to balance your time. You don't want to spend the whole time on the probability, you see.
Yeah. So that means
my advice just if you can solve the problem, you just move forward. Okay.
Yeah, that's right. Yeah. We have one more lesson, I think, before the exam. The exam's next Tuesday, so I got 1 week. But I think if it's okay, I could do next week.
Remember
2 hours on Monday.
Yeah, remember ask your teacher that can we use both combination and also probability methods to solve the same problem.
Yeah. I'll double check. Is it okay if we do 2 hours on Monday next week? Just before the night of my lesson, because I have the exam on.
All right, if
Tuesday.
if you have a super time, you can book in one more hour, no problem.
Yeah, I'll just switch with Ryan. Switch with Ryan's. Yeah.
Okay. Switch with Ryan.
Then, I'll just save this real quick. Yep, got it. Yep.
Okay.
Yeah. Just save.
Yes, save that. I will save that too.
Could you go to the next page, please? The next one. I don't think
number 3. Is what?
Yeah. I just saved this real quick. I got it.
Yeah, just that's it. If you have a chance, just stress this issue. Now, how do we determine the population? Okay, simultaneously. Yes. Okay.
Oh yeah, that's right then. Is that it?
That's 4. This is another page. That's the page.
Oh yeah, I just changed this one. I got it.
Okay, that's the first page is Victor's first page.
Yeah. Oh, I already got this one. Don't worry about that one. Yeah, I got this one.
Okay.
Yeah. Is this? Oh, it's yeah. What's the time? Oh, it's 8:30. Oh, okay. 33. Never mind. All right.
We can continue next time. Yeah.
I see you next week on Monday.
Okay. Monday. Okay.
All right. Yep. Good night.
Good night. Goodbye.
Bye.